The week after. Next week, we're studying. All right, guys. We are going to dive into review. If you haven't yet, pick up that review. I'm going to do like every other question with you. So 1 through 4. Luke, you got this? From the front of the room? All right. Yes, if you didn't submit that scavenger hunt, I will move that. Thank you so much. Thank you so much. I think you guys submitted that last week. The scavenger hunt? Oh, yeah. Thank you. Thank you. Some of you, I checked it off on Friday. Others of you need it. All right, guys. Quick reminder. If you have an odd degree with a positive leading coefficient, then yes, it's down up. If you have y equals a negative in front with an odd coefficient, up, down, nice, Jace. If you have y equals a positive coefficient with an even exponent, up, up, awesome. And if you have y equals negative x with an even coefficient, down, down. Okay. So let's just do one of these together. Like number 1, this is standard form, so you don't have to add any exponents. You're just looking at this first piece. It's a negative leading coefficient or negative, leading coefficient with an odd degree.
Up, down.
Yep. So which one of these is up, down? Correct. So number 1 is A. I'm going to skip because some of these I want you to come back to and try on your own. Number 5, it says complete all the information for the given graph. Do you guys remember how to identify the zeros? Nice. When we put them into factors, we're going to have to do the opposite. You're right. So this is x equals 1. This one is -1. This one is at -3. When I'm listing the zeros, should I list the y-intercept? No, good. So we just have those 3 zeros. -3, -1, and 1. Should this have a positive or a negative leading coefficient? How do you know that?
Because it's up, up. So
Good, nice. Up, up, so it should be positive. Should it be an even or an odd degree polynomial? Even, because the ends go the same direction. You could even put in that if you need to study that. Same ends. Now, how do we take the zeros and go back to factored form? Reverse them. Good, so it'd be x.
+1.
Good.
X +3. X minus.
Nice. Now wait, hold up a second. If I looked at this is 1, 1, 1. Yep, we do say y equals awesome. But yeah, you guys said that this had to be an even degree. But right now, if I count those up, it's odd. So Luke noticed something that we all need to notice. One of these is going to be squared. Nice. This one bounced. So it should be a square around the x plus 3. Now, if I add those up, it's x to the 4th. It's all good. Chase. So you look at the 0. If it doesn't pass through the x-axis, it's called a bounce. I think I'm hearing you right. You're saying it goes straight up like that.
Yes.
Yeah. Yep. That's a bounce. So then that we should have a exponent of 2. Nice. All right, let's go on to number 7 or 6. Number 6. First of all, do you know how to recognize what the zeros are? Yeah, you take the opposite, you set them equal to 0. So what's the first 0? Good. What's this one? 2. So we're going to go -1, 2, -3. Oh, so 0 would be if you had like number 7 is going to have 0.
Oh, okay.
Because there's an X on the outside. Good. But number 6 actually doesn't have 0. What's going to be the end behavior? How do we know that? You guys know? What do I do with those exponents to determine? Add them. Good. So this is going to be a -x cubed. And if I really multiplied it all out, it'd have a bunch of jargon after it. But since it's a negative leading coefficient with an odd degree, if you need to study that, you really, really want to study this. That means it's going to go up, down. So I'm going to go from the zeros, I go up, and then I go down. And now what's going to happen at -3? Should I go through? Good. Because it had -3 came from a place that had an odd exponent, it's going to go through the x-axis. So that means at -3, it goes through it. That also means when I find my y-intercept, it should be in the negatives. Speaking of the y-intercept, how do I find that? Plug in 0 for x. Awesome. So we're going to do opposite of 0 plus 3 times 0 minus 2 squared. If you have your calculator, you can literally just type that in. You can type it in exactly as you see it, and your calculator will tell you what your y-intercept is. If you don't have your calculator, then make sure you know your order of operations. But I can show you that the opposite of 0 plus 3 times 0 minus 2, oops, parentheses squared is going to tell me that it should be at -12. If you did that by hand, just follow your order of operations, parentheses first, then exponents, so that'll become 4, then multiply, so -3 times 4 gives you that -12. So the y-intercept, if I asked you to list it as a point, would be at 0, -12. So now I'm going to go to the y-axis and go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Go all the way to there. Come back up. Now here's the beauty. If you get most of these pieces, your graph is going to finish itself for you. I can't go through this because then I would create another 0, or really knowing the pieces, this guy came from an even factor. So should it bounce? Yeah, it's just like jump off of it. We say bounce. You don't have to think bounce. You just have to know it doesn't pass through. It's going to turn off it, like the way Jay said that too. Is that all? Does that remember? You guys remember that? Okay, I'm going to save these two for practice. We're going to have a lot of time at the end. Let's go to number 9. Sketch the graph of each of the following. Clearly show where the x or y intercepts are. Make sure you label the asymptote. Do you guys remember what the parent graph would be for number 9? It's y equals. Remember how we find it? Okay. Comes from this guy. You're thinking about the table that we'll use, which is great. But what's the function? So Candace reminded us that we'll need a table. What should I plug in? I'm going to plug in -1, 0, and 1. But where do I plug it into? So actually, you don't use all that other stuff because that'll get confusing. Just 3 to the x. So the parent graph is basically you take all the pieces away from x. Take away the +2, take away the +1. Now, if you plug in -1, do you guys remember what 3 to the -1 becomes? Close. 1/3, good. Do you remember what happens when you plug in 0? What's 3 to the 0? 1. Do you remember what happens when you plug in 1? 3. So these points, I'm going to plot -1, 1/3. So I go -1, 1/3. I'm going to plot 0, 1, 0, 1. And I'm going to plot 1, 3. This is not the actual graph. This is the parent graph. So it goes like that. Now I go back to that +2, that +1. Do you guys remember how the +2 changes the graph? Nice, Kira. Left 2. How will the +1 affect the graph? Up 1. So I'm going to start with any point I want. I could start with this one right here. Go left 2, up 1 whole value. If you were at 1/3, you have to go up to the next third right there. This one, I'm going to move left 2, up 1. This one, I'm going to move left 2, up 1. all these points, which were approaching 0, shifted to the left and then up. So they're not approaching 0 anymore. Where are they approaching? 1, good. In fact, the points are going to continually get closer and closer and closer, but never touch that 1. So it has an asymptote. What would be the location of the asymptote? Good, y equals 1. And then I want you guys to practice 10 on your own, but just to start, what would be the parent graph? Y equals 2 to the x. You actually take away the negative. You take away the -1. The negative will transform your graph. It's either going to reflect over the x or the y axis. The -1 is either going to shift it left or right. But I'm going to let you guys practice that one. Let's go to number 11. Oh, my numbers are all over the place. Change to exponential form. Remember how to do this? So it's log base 2 of x equals 5. How do I convert it? How do I change it to the other form? Drop the base. 2 raised to the 5th. Good. Perfect. You guys got it. That's it. That's the change. I'm not going to do 14 with you. I know it should have been 12. That's it. You should have converted it. They start off easy, get a little bit more difficult. Okay, once you know how to do that, you should be able to do some math with it. Like, can you evaluate? So if I ask, what does this equal? 2 raised to what power equals 4? Yep, 2. So that answers 2. And all I did was convert. I dropped it, and then I went around the world. Okay, these properties, I know we kind of learned them using like squares and you guys put equations together. You need to know these. So I'm going to write them real quick right here so you don't have to look back through your notes of what are they. Log base anything, so I'll say base b, of one number a, plus log base that same base, so in this case b, of c. How do you bring those together? It's going to be the same base, and you multiply. What do I multiply? So yeah, these guys, the numbers you take the log of. Good. So log base b of a times c. What if instead it was the same thing, log base b of a minus log base b of c? How do you bring those together? Divide. Good. So it'd be log base b of a divided by c. And then there was one more. If you had like c times log base b of a, how do you work with that guy? You put it as the power, right? So which one becomes the power? C. Good. So we'd have log base b of a to the c power. So basically this guy just jumps up on top as an exponent. These you need to know. And then you remember if you're combining, which one you use first. Like what should I do first here? I see two properties. I see a minus, I see a 2 out front. Good, we want to do the power first. So that would be natural log of x squared minus, oh, you guys haven't seen natural log. It's a log. We didn't hit on it here. It's, you don't need to know this. Just know it's a log. It's called log base e. We didn't talk about e. E is like pi. It's 2.718. Just with where our curriculum went, we didn't get to that. Do you want me to change it? Is it going to really confuse us? Okay. Okay. Let me change it. Cross that off. Cross that off. Let's call it 2 times log of x minus log of z. I did not give you a base. Good. If it's not written, it's understood to be 10. Okay, now do you guys remember what we do? Still do that power first. Same steps. But instead of having ln, it's log of x squared minus log of z. And then what do we do with that minus? Divide. So it becomes a single log with that base 10 of x squared divided by z. And that's it. I will not give you an ln on tomorrow's test. Sorry about that, guys. All right. Then this one says use your properties. You're doing it again. But at the end, you need to actually determine the value of the log. So you'll convert it. I'm not going to do this one with you because I want you to practice it, but I'm going to tell you that that word means at the end, convert to find the answer. Okay, and then if you notice, all of these, they were on the non-calculator portion. Hopefully you haven't had to really reach for your calculator too much yet. I may let you use the calculator, but you have to show me all your steps. Number 19, when I say no calculator, I don't want you using logs to solve. Well, what do we, it's not divide. We're saying 3 raised to what power gives you 9. You want to try to make this guy and this guy the same. So if you take 9 and make it a square, 3 squared, right? You guys know 9 is 3 squared, right? And then the other side is just 3 raised to the x minus 4. Now what do? Solve it. How do I solve it? The exponents, good. X minus 4 has to be 2. Only 3 squared can equal 3 squared. So I mean, you could think of in your head what number minus 4 gives you 2. Or if you don't want to think that hard, just set them up. And then solve. How do we solve for x? Add 4, add 4. And you'll get x is equal to 6. There will be one like this on the test tomorrow. You want me to give you a practice one and just, I'll show you the answer later. So let's do 4 raised to the x plus 1 is equal to 16. I'm not going to solve it now, but I will have it on the answer key up on campus. Let's go to number 20. Now it says you may use a calculator. When it says you may use a calculator, that's when you know you need it. Like I need a calculator for tomorrow to be able to solve with the logs. Solve for x, leave all answers in exact form and round it to 3 decimals if necessary. So number 20. Do you guys remember which one's the base? 3 is the base. Step 1 is to isolate the base. The base is by itself here. What would I have to do in the next one? I'd have to add 1. Good. So I'm glad you guys know that. But this one, the base is by itself. How do I solve? And I can't write 9. I can't write 10 as 3 squared. It's not that easy. So what would we do? So go around the world of 10 equals 2x minus 3. Do you guys remember how to enter this guy into your calculator? Alpha, good, alpha window. Yes, number 5. And then how am I going to get x by itself? Add 3. So I'll have log base 3 of 10. Should I add 3 and say 13? No, remember this guy, it's by itself. Is equal to 2x. And then how do we get x by itself? Divide by 2. Now, if you didn't have your calculator, or even if you do, this is the exact answer. It's not rounded. You solved for it exactly. Log base 3 of 10 plus 3, like that, divided by 2. In your calculator, we're going to have to do that exact same thing. Do you remember how to enter in a fraction? Alpha y equals n over d. And then I can do alpha window log base. I need number 5. Log base 3 of 10 plus 3 divided by 2. And it tells me that exact answer is 2.548. And I Put that in. I am gonna give you guys like 10 minutes to work here in a moment. If you don't have a calculator, I would borrow one from me and complete the calculator once before you leave today. You too. Okay, I'll let you too. All right, let's go to logs. This is what you did all around the room on Friday, the scavenger hunt. This first step is to isolate the base. We'll do 2 of these together. Let's look at 20, or to isolate the log. Sorry, there's no base. Isolate the log. Yep, this one's already by itself. So you do what Amanda said, you convert it. How do I convert it? Drop the 5, good. 5 raised to 0 power equals. Awesome. Yeah, 5 to the 0 is 1. If you don't remember that, you could put it in on your calculator. And then you solve from there. So we add 3, giving us 5x is equal to 4. Divide both sides by 5. Perfect. That's good. Yeah, that's exact. It says exact and rounded, but I mean, if you put that in on your calculator, I'll take this just because it's so nice and pretty. 0.8, 40. Yeah, 0.8. Okay, let's do 25 together. 25, you have 2 logs. How am I going to make them into 1? There's something. The properties. Good. So you're going to make the power first. So it'll be log base 3 of x squared plus log base 3 of 25 equals 2. You multiply them with those properties. Perfect. So you have log base 3 of x squared times 25 is equal to 2. Where do you go from there? Convert. Perfect. So bring down the 3. 3 to the 2nd power equals x squared times 25. What's 3 squared? 9. We got 9. And then it's all good. It's a Monday. And then how do we get x squared by itself? Divide both sides by 25. I gotta get x alone. Right now it's being multiplied by 25. So now we have x squared is equal to 9 over 25. Square root. When you take the square root of a fraction, yes, you square root the top and bottom. What's the square root of 9? 3. What's the square root of 25? 5. Usually, we have to remember the plus and the minus. We cannot take the log of a negative, so we cross off that minus. Good stuff. You have like 10 minutes. Your homework is to finish and check your answers. Yes, I'm going to be posting the answers on campus in about 15 minutes. You do want to make sure you check those tonight. Yeah, go ahead, grab that one. Yes.